Okay, now welcome to the second video. The second video is types of matrices. So, types of matrices. The number one, row matrix. The name itself is very clear. Row matrix. See the example. 1, 5, 7. What is the order? We have one row and 3 columns. So order is 1 by 3. Another example. 1, 5. One row, 2 column. Another example. 1 row and 1 column. What is the common among all 3 matrices? Every matrix has only 1 row. So if a matrix has only 1 row, it is called row matrix. Correct? So if a matrix has only 1 row, it is called row matrix. See the definition. A, Ij, only 1 row. There is no limitation for column. So this matrix is called row matrix. Now, second matrix is column matrix. Again, the name of the matrix is column matrix. See the example. 3 rows but 1 column. Another matrix. 2 rows and 1 column. One row and 1 column. So what is the common among all the 3 matrices? Every matrix has only 1 column. So if a matrix has only 1 column, it is called column matrix. In the symbolic form, A is a matrix called column matrix if number of column is 1, there is no limitation for number of rows. Number of columns would be 1. Alright, number 3. Is a rectangular matrix. Rectangular matrix means rectangle. Rectangle means obviously length and breadth. Here length is like row and breadth is like column. See the example number 1. 1, 2, 4. How many rows are there? 1. How many columns are there? 3. So number of rows and number of columns are not equal. Means length is different, breadth is different. So that is called a rectangle in simple language. So when the number of rows and number of columns are not equal, it is called a rectangular matrix. Correct? 1, 2, 5, 7, 3, 9. What is the order? 2 rows with 3 columns. Number of rows and number of columns are different. So it is a rectangular matrix. So one thing more I want to clear it. How many rows are there? 1. So it is also a row matrix and a rectangular matrix. It is purely a rectangular matrix. Correct? So in the symbolic form, a matrix A ij of order m by n. This matrix is called rectangular matrix if number of rows is not equals to number of column. Correct? Now number 4. Square matrix. So it is again, I think so, it's a simple one. Number 4 is square matrix. See, a matrix of order 1 by 1, number of rows and number of columns are equal. Number of rows and number of columns are equal. Three rows, 3 columns, the order 3 by 3. Number of rows and number of columns are equal. Correct? So these are square matrix. So in the symbolic form, see, matrix A ij of order m by n is a square matrix if number of rows and number of columns are equal. Correct? So it is very important matrix of the chapter, square matrix. So remember, a square matrix is a matrix whose number of rows and number of columns are equal. So in a square matrix, few things are involved in the square matrix. So we have to discuss those things also. First thing is, there is a term called main diagonal or leading diagonal. Alright? Or principal diagonal. Where is this diagonal? Remember, these terms, main diagonal or leading diagonal or principal diagonal, are same. It exists only in square matrix. Take the example of a square matrix 2, 7, 3, 5. Order is 2 by 2. This is the first element of the matrix and this is the last matrix element of the matrix. So this is called leading diagonal or main diagonal or principal diagonal. Correct? Means the diagonal joining the first element and the last element of a square matrix. So this leading diagonal consists two elements, 2 and 5. The smallest square matrix is this 1 by 1. This is the leading diagonal, which consists only one element, that is 5. And see this matrix 1, 5, 7, 9, 3, 2, 5, 2, 1. Order 3 by 3. First element and the last element. This is the leading diagonal, which consists 3 elements 1, 3 and 1, 3 and 1. Correct? So this is leading diagonal. Now one more thing. See the nature of the leading diagonal. A11, A12, A21, A22. This is the square matrix. If it is a square matrix, it consists the leading diagonal and here is the leading diagonal. See the symbol A11, A22. This is the speciality of the leading diagonal element. Leading diagonal element consists same number of rows and columns. Means if I'll ask, can A53 be the part of leading diagonal? Answer is no, because the element of the leading diagonal has equal number in the suffix A55. Yes, there is a possibility of this element to be the part of leading diagonal. So leading diagonal element always consists same suffix. A11, A22. This is called sum of elements of leading diagonal, and this sum is called actually trace of matrix A, or in the short form we write trace of matrix A. If it is the matrix of 2 by 2, so the leading diagonal elements will be A11, A22, so the sum is A11 plus A22. Suppose we have a matrix of order 3 by 3. Matrix of order 3 by 3. So what will be the trace of that matrix? Will be A11 plus A22 plus A33. If we have a matrix of order 4 by 4, so trace of the matrix will be A11 plus A22 plus A33 plus A4. But remember, the matrix should be the square matrix. Correct? So this is the term which is related to square matrix. Now, next category of matrix. So it was square matrix and the terms which are related to square matrix. Now come to the next matrix, which is called diagonal matrix. There is a term involved in the name is diagonal, means somewhere it is related to leading diagonal. If it is related to leading diagonal, it must be a square matrix. Example, square matrix. So there is a leading diagonal and these are the elements of the leading diagonal. If these elements which are non-leading diagonal elements, if the non-leading diagonal elements are 0 and leading diagonal elements are not 0, so it is called diagonal matrix. Correct? So for diagonal matrix, non-diagonal elements should be 0 and diagonal elements should not be 0. Take the example of 3 by 3, that will be more clear. 1, 2, 3, 4, 5, 6, 7, 8, 9. This is the leading diagonal. These are the non-leading diagonal element. So make it 0. So this is diagonal matrix. Next is scalar matrix. Same figure, do one thing. Non-diagonal elements should be 0 along with, or all diagonal elements should be non-zero. But one more speciality, make them equal. So they are not 0. Along with this, they have one more speciality, that they all are equal. It is called scalar matrix. If the leading diagonal elements become same and rest of the elements are 0, so it is called scalar matrix. So scalar matrix is also a diagonal matrix. The most important, make them equal, but take it as 1. So this becomes identity matrix. Correct? So the symbol will be changed. This is the identity matrix. Identity matrix means non-leading elements should be 0 and leading element should be 1 only. So this is called identity matrix, whose order is 3 by 3. So 1, 3 will be written over here. So 3 stands for identity matrix of order 3 by 3. Go for the second. example that we have to use in the exercise. I2 means identity matrix of order 2 by 2, and the representation of I2 is here 2 by 2 1 0 0 1. All right, so this is identity matrix 1 0 0 1. All right, so identity matrix of order 2 by 2. So actually we don't have to use I3, only we have to use till I2. I2 means identity matrix of order 2 by 2, and this is the identity matrix. Correct? Now, null matrix or zero matrix. Need not to explain it more. Null matrix means whose. Now, null matrix or zero matrix. Correct? So null matrix or zero matrix. Symbol, very simple. If a matrix whose all elements are zero is called null matrix. So like null matrix of order 1 by 2, null matrix of order 2 by 3, null matrix of order 2 by 2, null matrix of order 3 by 3. So the symbol will be this, not. Correct? So there is no restriction for null matrix to be a square matrix. So any matrix can be null matrix, but the condition is all elements should be 0. So in the first video, I told you the introduction, the representation, the terms related to matrix, and in the second video, I explained you the types of matrices. So go through the video properly and ready with the information that I have given in the 2 videos, so that you can be comfortable when I will be taking my online classes. Thank you.